All right. Hopefully this is streaming on YouTube. This is Perp Radawa, Austin, Texas, 12:52 p.m. Tuesday, October 17th. Amazing weather outside. I was gonna watch a Vitalik talk, and I thought I should stream it. So it's kind of funny that I'm streaming YouTube on YouTube. But it's a copy of this also goes on my website. I also wanted to talk about a couple of other things, and I'm talking into my MacBook Pro, so I don't know how good or bad I sound on the other side, but I just wanted to talk about the fact that I paid my taxes yesterday, and it was a weird experience because it's like I've never filed my taxes with a long list of crypto transactions. So last afternoon yesterday was the first time I was like sitting in front of me with all these crazy NFTs, the silly pictures and all the fucking transactions, and it's like I filed it through TurboTax, and every other transaction it was like you need to explain what this is. So I was sitting for NFT transactions and crypto transactions, and I thought I'd catch up today or the day after on what's going on with crypto, because I do it as a part-time thing. I do it as a hobby thing, so I don't always keep up with what's going on, but I just thought it was funny. The other thing I wanted to talk about is that I'm going to be attending Stephen Wolfram's conference. I think it's on November 1st, so it's in 2 weeks. I'm a big physics fan. Like crypto, I do it as a hobby. So I'm sure I'll be meeting people who do it at a more serious frequency than I do. But I'm hoping to combine that. So in preparation, I'm going to combine that with my knowledge of crypto. So in preparation of it, I'm trying to catch up what's going on in the crypto market, make sure all my taxes are paid, look up what people are doing in the name of crypto. So yesterday I was catching up on like stable coins, and today I found this report by JP Morgan, just a Chase Bank in the United States. So they have a report in digital identity passing around in within their organization and other organizations, and I just thought it was interesting that they list a couple of NFTs that I own. Like I own a bunch of ENS names, soulbound tokens, credentials, loans, collateral, options trading, all of that. That's my wheelhouse of crypto. So it's interesting to do that, but I thought I'd stream Vitalik's talk in case anybody else might like it. So I'll stop talking and start eating pizza and look at what crypto's up to. All right, see ya.
So who here remembers the Ethereum white paper? Who here has read the Ethereum white paper? Any part of it? This is a document that we published back in 2014 that basically describes some of the initial vision that we had for the project, right? And in the white paper, we describe some of the basic ideas behind Ethereum, and basically that Ethereum is this decentralized system similar to Bitcoin. It's a blockchain, except the big difference is that unlike most of the previous systems that existed before, which only tried to support one application, Ethereum has a built-in programming language which allows the users to build their own applications, so that you can write your own application on a piece of code, then you upload that code onto the blockchain, and then that application runs that code, and that piece of code is your application, right? So you need to just blockchain is not just supporting one application. The blockchain basically lets anyone create their own applications that then get added on top. Right, so anyone can write their own applications and upload them, and these applications can talk to each other. Anyone can use those applications, and they're all part of the Ethereum ecosystem. So at the beginning of this white paper, I talked about some of the ideas that other people have had, some of the ideas that I have been starting to have. So colored coins is one of the early protocols on top of Bitcoin for issuing your own assets. So today on Ethereum we have ERC20, but back then we had colored coins, and colored coins was this early attempt at making a protocol for issuing your own assets on top of Bitcoin. Actually, what's interesting is that very recently there's a very limited and very specific version of colored coins called Ordinals that is on top of the Bitcoin protocol. So actually, something like colored coins on Bitcoin is having a bit of a comeback, right? But colored coins are only one application. You can have tokens that represent access to physical objects. That was called smart property assets. You can have other kinds of assets, like domain names are a good example. Right? So you can basically have a system on the blockchain for registering websites, registering usernames, keeping track of names that users and applications use. And then you can do this in a decentralized way that you will all enjoy. The concept of smart contracts, this idea that you can have computer programs that live on the blockchain, and those computer programs can directly control digital assets, right? So an asset does not need to be owned by a person, an asset can be owned by a program. And this concept of smart contracts can be used to implement many kinds of more complicated applications. So for example, you can have prediction markets, you can have financial gadgets, things like stable coins, like leverage, all of the different things that DeFi offers. Then there's this concept of decentralized autonomous organizations, which is basically using a smart contract to implement the voting logic or governance logic of an entire organization on chain, right? So instead of dispute resolution for an organization needing to be done by a legal system, you can have this very low-cost way of just doing that directly on chain. So a lot of the concepts in terms of applications have basically been here since the beginning. And a lot of these concepts have basically stuck even until this day, right? So a lot of these concepts have, we have these things today, right? We still have, back then we had colored coins, today we have ERC20. Back then we had smart property. Smart property actually has not really seen that much progress, but we do have on-chain over there. Namecoin, we have EMS, and lots of people use EMS, right? So my own blog actually is uploaded to and it is accessible through EMS, right? So if you use Ethereum enabled browser, like I believe if you use Brave, you can do this. You can type in develop.eth and you just get the front page of the blog, right? So it's something that you can use and it works. Smart contracts and DAOs, there are many kinds of DAOs worldwide that use many different kinds of projects. So far, just haven't really seen huge adoption outside of projects within the DeFi ecosystem, but they exist, and many of them have been operating pretty well for years. So that's some of the applications that we've seen, right? Now, there have obviously been other applications that have come in that have just completely surprised me. So NFTs are a good example. I did not predict CryptoKitties. I did not predict, the monkeys. I did not predict NFTs. But a lot of the other things that exist today are basically very similar ideas to what we had 20 years ago. So research on proof of stake, right? So today, Ethereum finally is a proof of stake chain, right? And proof of stake has greatly increased Ethereum's security. It has reduced Ethereum's energy consumption by more than 99.9%. So before what was called the merge, the full switch to proof of stake of Ethereum last year, Ethereum consumed about, I think, as much electricity as 40% of Singapore, and now that's reduced to basically So it's proof of stake transition is finally complete, but this is a thing that we have been working on in the ecosystem for the last 10 years, right? So the first 5 years of proof of stake development were basically us trying to understand what proof of stake is, what all of the different options are in the proof of stake space, before finally converging on what the particular version that actually works. Right, so this is a picture from a blog post from 2015, where I would basically describe a mechanism called consensus, which attempts to essentially have validators send a series of messages expressing higher levels of confidence in a particular block in order to try to agree on a block much more quickly than you can improve a block. So it turned out that consensus by get had a lot of flaws, and it was needlessly complicated, and it was actually much worse than kind of much simpler protocols that ended up turning into Casper FFG. But it was, a step along the road to us understanding the space better. Now, actually, for anyone interested, I made a Twitter thread back in 2018, and if you want to see it, just scan that QR code. And basically, in that Twitter thread, I go through the journey of Ethereum proof of stake research, and basically how we went from first starting to explore and being okay with maybe proof of stake and proof of stake at some point in the future, until we finally decided on the exact algorithm. So first 5 years was research, then next 4 years after that was development. Scalability, right? So scalability is this super important thing for Ethereum, right? Because as of today, the Ethereum blockchain only supports somewhere between 10 and 20 transactions per second. And between 10 and 50, actually, depending on how complex and how large the transaction is. Now, this is a very small level of scalability, right? If you want to support mainstream finance, mainstream payments, and systems at a global scale, you need to have something closer to 100,000 transactions per second, right? If you only have 20 transactions per second, the world population is 8 billion, so it would take 400 million seconds, which is about 13 years for people to be able to do something on chain even once, right? And so increasing scalability is just a very good thing. Now, the very early effort in improving scalability was called sharding, right? And what we're doing still is a form of sharding, right? But a lot of different things have been designed and changed to this mechanism since then. So the idea of sharding basically is this: a simple blockchain has limited scalability because it requires every single computer on the network to process every transaction. So let's change the design. Instead of every node processing each transaction, every node only processes it's like how Bitcoin works. Bitcoin has a share with any but like Bitcoin is not requiring literally every person to store everything, right? Because that would just be way too much data for them. And so the challenge is like, how do you do some kind of Bitcoin and still having the consensus system so that people are agreeing on what order so that you can build that finance. This was a hard technical thing. This is one of our earlier ideas. This is 3 levels sharding, where you basically split up nodes into groups, individual groups and vote on individual things that happen. It's a very complicated construction. Push the complexity, sacrifices to push the complexity. in Taipei, where I basically talked about what some of the most important problems in Ethereum are. And the four I mentioned are pretty simple, right? Privacy, consensus safety, smart contract safety, and scalability. And if you listen to me or like anyone else talk about what are Ethereum's biggest problems today, you get basically the same answer, right? Privacy, consensus safety, smart contract safety, and scalability. So the challenges are the same as the challenges were 6 years ago. But at the same time, what is I think is interesting is some of the some of the progress that has been made since the 2017, right? So 2018, the Beacon chain, right? This is when we work on Ethereum's proof of stake really switched from research to development. And this is where we had this big workshop in Taipei, and then later had another workshop in Berlin. We really came together, we agreed on approximately what would be the design of Ethereum proof of stake, and we switched to actually working on building it. So this is an early diagram describing what the Beacon chain, what proof of stake and sharding would look like. This is actually not what it looks like today, right? What it looks like today is even simpler, right? So we've been continuing to push complexity down more and more as much as we grow. But this is what it looks like in 2018. Now, in 2023, the status quo of Ethereum from a usage perspective, right, is basically that in many places, there's few people who are using crypto, and people who are using it to do things like trading digital monkeys. In many other countries, very many people are using it, but a lot of the time they're using centralized exchanges, right? There are many countries around the world where, for example, there's more than 10% of the population holds cryptocurrency, right? Like you hear statistics like this from places like, Argentina, Turkey, Nigeria, Ukraine, many countries that have different kinds of complicated political or currency situations. And in those places, like being able to have this alternative means of transacting and holding savings is just a lifesaver for people, right? And it's valuable for people already. But the challenge is that when you look at how these people actually use the cryptocurrencies, you're always going through centralized exchanges. And centralized exchanges can be good and they can be convenient, but as we found out last year, centralized exchanges also good. So one of the ways that I see the challenge is basically that in trying to find ways get to the point where we can actually have more people using, not just cryptocurrency, but like actually using the blockchain and like actually benefiting from, the openness and the kind of global permissionless and decentralized nature of the technology. So problems are the same as today, but there has also been a lot of progress, right? So if you look at privacy, for example, in 2017, privacy was just a technical challenge, right? Basically, there's this new type of cryptography called ZK SNARKs, right? It's also called zero knowledge proofs. And what this lets you do is it basically lets you create a cryptographic proof that proves certain, like any mathematical property, like anything that can be computed on data that you have without revealing anything else about that data, right? And this was used first by Zcash. Zcash is a privacy-preserving cryptocurrency that launched in 2016, and Zcash used ZK SNARKs in order to achieve privacy, right? How do you do this? Basically, when you spend a coin in Zcash, instead of pointing to directly which coin it is that you're spending, you make a proof that proves that you are spending a coin that you have that has not yet been spent without revealing anything else about that coin. Right, so you're proving exactly the statements that you need to prove to have a currency system that does not hyperinflate, but everything else is being kept private. And back in 2017, the challenge was just importing the ability to use that technology onto Ethereum. ZK SNARKs rely on a very complicated piece of math called elliptic curve pairings. And in the Byzantium hard fork, we basically added some what are called precompiles that basically a kind of opcode that let you use pairings, verify pairings inside of Ethereum. And so using smart contracts, you could actually build an application on top of Ethereum that has the same kind of privacy preserving logic. That was 2017. In 2023, the status quo technologically is very advanced, right? There are very advanced ZK Snark libraries, development environments, tools, protocols. We have Plonk, Halo2, Plonky2, Starknet Air, Cairo, just like this big long list of really fun and fascinating technologies. But privacy actually hit a different kind of bottleneck, which is basically legal issues and issues around coins coming out of these systems getting accepted by the wider ecosystem, right? So there have been legal issues around Tornado Cash, which is basically, you can think of it as a clone of Zcash that sits on top of Ethereum. Basically just because hackers ended up using it a lot. And as a result of this, there has been work coming out on a concept called proof of innocence, which is basically, what proof of innocence lets you do is it lets you prove that your coins that came through your privacy system also do not come from one of the hackers. Right, so you're proving that you're not one of the hackers without without completely revealing where your coins came from. And that actually there's a paper coming out about this idea soon. There's already several implementations from Chainway and some other companies. So basically there's a lot of this work in the details on trying to modify these privacy systems to increase the chance that if you actually use one of these privacy systems and then you go and deposit those coins in an exchange, then the exchange actually will accept those coins and will not get maximally suspicious of you. Also, ZK Snark verification, making it cheaper, right? It costs about 400,000 gas to verify a proof. We want to make verifying proofs cheaper. Part of that is layer 2, part of that is aggregation protocols. So the difference between 2017 and 2023 is that in 2017 we were just trying to make the basic building blocks work, right? In 2023, the building blocks work, but the focus is on optimizing those building blocks and on doing a bunch of this more complicated work on trying to make it fit in together with the mainstream. Consensus safety. In 2017, we were basically just finishing the research part of the proof of stake development process, and we were just starting development. In 2023, Ethereum has fully switched over to proof of stake. We've become a fully proof of stake system, but the challenges have to do with reducing the complexity of the protocol, improving the security of the protocol, addressing centralization concerns, or making it easier for people to stake, making a concept called PDS that makes it again easier to stake because you don't have to run complicated algorithms to optimize how much revenue you make. Smart contract safety. I feel like smart contract safety has kind of maybe advanced the least out of all four of these, right? Because in 2017, we were only 1 year after the DAO hack, right? Who remembers the DAO hack? Basically, one of the very first big DAOs. This was a smart contract that controlled about $150 million and used it and was intended to be an investment plan. It got hacked, and basically the hacker actually tried to get away with quite a lot of money, but then actually Ethereum ended up forking to basically return the money to the DAO's original owners, and so that was the only time anything like that happened in Ethereum. And so back in 2017, this memory was still fresh in everyone's minds, and everyone was very worried about this kind of security. And so people were working hard on improving the security of the programming language, making contracts safer, making everything safer. And in 2023, a lot of that work has succeeded, and I think the amount of hacking happening has quietly reduced. And when it hasn't reduced, it's because people try to build things that are 20 times more complicated, right? If you're building something today, which is not 20 times more complicated than what people were building in 2016, you're generally actually quite safe, right? There have been lots of systems that have survived for years without being hacked, and I think that's a very impressive accomplishment. There's other kinds of safety that have been improved. So in a few months after the DAO fork, there was something called the Shanghai DOS attacks, where basically an attacker took advantage of a lot of bugs within the Ethereum protocol itself that made it possible to send transactions that basically slowed the entire chain down. And we just worked for months, basically releasing an update every day, and the hacker kept finding a new bug every day, basically fighting against and finding all of these bugs. And eventually, after 4 years, through a series of different changes and improvements, then EIP 2929, also a lot of improvements to the Geth code base. Right, the Geth developers have done some really amazing work. And at the end of this, a lot of those security problems have basically actually kind of quietly been solved, right? The thing with security that's a little bit annoying is when you switch from proof of work to proof of stake, there's one big event, right? The merge. The event happens, and you can have parties in Berlin to celebrate. When you succeed in security, there is no event, because the whole point is that there is no event, right? But it's sometimes important to remember that the event's not happening as big news, right? So I think there have been real improvements there, but there's still a lot of ongoing problems. And scalability. So back in 2017, sharding was just an idea. We were also talking a lot about state channels and Plasma. These were these big layer 2 solutions. And then after that, around 2020, everyone switched over to rollups. And so today there's all of these different rollups. There's EVMs, there's optimistic rollups, there's non-EVM rollups. These rollups are actually starting to kind of take off their training wheels and become properly decentralized. Arbitrum made a major step toward that this year. Polygon made a major step toward that this year. There was ongoing work on decentralizing these systems further, hardening the group systems, making them more secure, making the group systems faster, so that with a secret EVM, instead of proving one block in 5 hours, you could prove a block in 20 minutes, and then maybe in the future it'll go down to 2 minutes, and maybe eventually 12 seconds. So, a lot of progress, right? And the areas are still the same, but there's just a huge amount of games that are being made on this. Lots of other things too. So virtual keys. 5 or 6 years ago, stateless clients were just an idea. Now virtual keys are a 10-person team that's written thousands of lines of code that's thought deeply about how to actually push this out onto Ethereum. It's maybe 1 to 2 years away from actual implementation. Improvements to the EVM Max, EVM simplification. Account abstraction. Account abstraction is this really big one, right? Everyone who supports account abstraction has a different reason why they support account abstraction. And I think the reason why is because account abstraction is inherently this extremely flexible thing, right? The goal of account abstraction is to basically say, instead of having accounts that are controlled by a key, you have accounts that are controlled by a computer program. If you have an account that's controlled by a computer program, users can have different kinds of logic for how those transactions get approved, right? So instead of having 1 key, you can have 3 different keys. You can have 5 different keys where some of them are controlled by other people. You can do multi-factor authentication. You can have keys that are stored in trusted hardware modules that exist on any modern phone. And you can have more secure ways to authenticate them. You can use hardware wallets, and you can combine multiple hardware wallets together, right? You can get a lot of these different options. You could even do really things potentially use an email account as a way to authenticate yourself as a way to authenticate yourself into an Ethereum account, right? And using an email account to access an Ethereum account, it's
जाने भी दे क्यों बनती है मुझको गैरों में क्यों गिनती है
पहले पल में तू जैसा लगे दूजे पल में अपना सा लगे
आए यहाँ तक तो यार
So,
क्या
a lot of
जानम
progress being
समझा
made, a
करो
lot of different
जानम
things,
समझा
right?
करो
Now,
जानम
getting back
समझा
to,
करो जानम समझा करो
one of the events that I always talk about was this Riptide Argentina that I made back in 2021, where I was really impressed by just how many people did things were like actually using cryptocurrency, right? I remember on Christmas Day, I was just walking outside, and on Christmas Day, most things are closed, and so I just wanted to go and find a coffee shop. The first coffee shop that I found, the owner recognized me. He told me that he had a crypto wallet, and I asked if he could pay with me, and he said yes. And we answered that call. Actually, I did use Arbitrum, so
तुम मुझको अच्छी भी लगी
but there was a
बातों
problem,
के
right? You know, it's
सच्ची भी लगी फिर भी दिल तो डरता है धक 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 करता
डर क्या जब है साथ मेरा हाथों में है हाथ मेरा
रास्ते में मुझको छोड़ दो
मर भी जाए तो क्या गम है ना बिछड़ेंगे हम दिल वाले
है शहनाई का इंतजार
Like a lot of these other, essentially.
जानम समझा करो 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 जानम समझा
The problem is that decentralized ways for people like this to hold their coins just do not exist yet, right? And like trying to really improve and make things better for people on chain is like one of the really big challenges, right? So basically, we need to find ways for people to do things that really actually do benefit from the openness and the decentralization of a global information blockchain. And can we get to a world where like, in all of these areas of applications that like really people have been thinking about all the way since 2013, we get to a version that actually provides benefits and also actually works. So technical work, the whole time has been following a pretty consistent direction, which I think is fascinating. I think the tools have changed, right? The tools have changed a lot. 10 years ago, we were not even thinking about using them. Now we are. But the goals are the same. Now I think there's a lot more of a need to focus on like actual use and adoption. And the solutions involve technical work, but they're more distributed and they're more on different ways of doing that, right? So what this means is that like the Ethereum Foundation and the Ethereum core development teams and the client teams are not like the only place to do extremely important stuff, right? The smaller companies are also a place to do extremely important stuff. The application developers are a place to do extremely important stuff. Even like building enterprise blockchain systems, right? This is a thing that people have tried to do for many years, but I think if you build it as a Selenium, like a layer 3 on top of Ethereum, then like there actually is a way to make that viable and to make that like actually work for people who are basically actually provide the benefits of decentralization, but at the same time make it like actually possible for people to deploy, right? So I think those are like some of the biggest changes that we've seen in Ethereum over the last 10 years, right? Basically just a ability to load Ethereum and ideas is having to actually deal with exchanges that people
raise the thanks for tech voice sharing, and I hope the students learn enough how to drive a new technology and really influential usage. Now we have about like less than half an hour as usual for Q&A. The tech will understand here, so you can have access to the questions from okay, that let's